Yeah, so today we're not going to talk about singular learning theory basically at all. I think I have one slide. I want to talk about the bigger picture, the two cultures of AI safety. I'm going to start by doing something you should never do in a presentation, which is dump a big block of text on people. So take a second to read this. We're going to start in the 1800s, all right? Not with AI safety, but with geology. So, at the time, there was this big debate going on between two camps of geologists. On the one hand, you had people arguing that geological change is sudden, gradual, that you should start with the processes you can see in the present and work your way backwards. On the other hand, you had this camp that said that actually no, geological change is dominated by large discontinuities, rare violent events, and only if you understand those are you going to understand the large or macroscopic behavior of the planet. These camps were the Uniformitarians and the Catastrophists. Okay? They had their champions, you know, the Yudkowsky and Cristiano of their day. So Lyell argued for gradual observable processes, and Cuvier argued for the rare violent discontinuities. You know, this isn't the only hypothesis that they differed on. They differed on a bunch of other ideas about how you should approach geology as a field. So methodologically, the Uniformitarians are saying you should only start with the processes you can directly observe. Whereas the Catastrophists point out the anomalies and say these are precisely the events that are most important. Breaks in the fossil record, large extinction events. They're pointing to different kinds of events, right? Erosion, sedimentation, those are things you can see tangibly right now. The Catastrophists focused first on floods, okay, motivated in part or largely by the story and genesis of the flood. So maybe not an entirely rational approach to the problem, but they soon discovered new theories, glaciation theory, and eventually, in the late 20th century, the theory of asteroid impacts causing the mass extinction of the dinosaurs. Okay, the interactions weren't always civil. Okay, so the Uniformitarians accused the Catastrophists of being dogmatic, blind, not detail-oriented enough to really appreciate the fastidious study of the small changes that's needed in order to appreciate the overall macroscopic trends. And in the reverse direction, the Catastrophists are thinking, look at this break in the fossil record. Can you not see with your eyes? What is going on here? Please look. Eventually, we reached a resolution. Okay, what is that resolution? It looks like something in between these two poles. So, the sudden breaks in the fossil record initially. Then Lyell publishes this detailed account looking at, you know, exactly growing levels of sandstone in various cliff faces. You could study this in a very detailed sense and then come out with the perspective that yes, over deep time, over long periods of time, uniform change is the norm. The thing that started to turn people in the other direction was Agassiz, who presented strong evidence of a sudden ice age sweeping across Europe. Of course, Darwin, initially construed as something that's very much in the uniformitarian camp. Later on, within evolutionary biology, we would get the same disagreement between a gradualist camp and a discontinuous camp. But we'll put that aside for today. The thing that really turned the tides is evidence of this colossal flood that swept across Washington state in the early 1900s. And the thing that really clinched it was, of course, the evidence for the impact that killed off the dinosaurs. Okay, so what we have today is a synthesis of the two fields. Historians of science say neither side was totally correct. You know, the evolution of the planet is both gradual and slow, and you have these occasional large violent events that are really important. I think it's important to focus on this historical example because these aren't just different hypotheses, they're different cultures. They have these different starting beliefs, but they have these different methodological approaches. And the communities are different, right? They're located in geographically distinct places. That resolution we eventually got, I think is most clearly articulated by Stephen Jay Gould, who pulls apart several of the correlated beliefs that characterize the uniformitarian camp. So first is the idea of uniformity of law. Physical law today should be the same as physical law in the past. Uniformity of process, the idea that only the processes you observe nowadays are the ones you should include in your hypothesis class. Uniformity of rate, the idea that change happens continuously, but at a steady rate of change. And then uniformity of state. Uniformity of law, everyone maintains to this day. Uniformity of state has been outright rejected. And so what we're left is with a discussion about these intermediate stances. Gradualism, also resoundingly rejected. But what survives is what's called actualism, this idea that you should focus on evidence observable today. Geologists now grant that there are events that you cannot observe happening in real time anymore today, but through a sort of principle of simplicity, you should focus on favoring the hypotheses that we still see today. That's just a simplicity statement. And so that's the dogma that we have now in the 21st century. Okay, and now for the rest of the talk, we're going to repeat basically this analysis with maybe some more tangible suggestions for the way forward in AI safety. It's 2 centuries later, and the question is now not what's happening in the past, but what's going to happen in the future. On the one side, you have the catastrophists. I'm going to be using the same language because it's neutral and any other choice of distinction was not really working for us. So the catastrophists say that on the route from here to artificial superintelligence, there will be some, maybe one, maybe multiple, large discontinuities. And most of the risk is concentrated in these discontinuities. The canonical example of this would be like an intelligence explosion, a recursive self-improvement loop. On the other side, you have the Uniformitarians who say progress will be pretty continuous from here on out, at least for some time past AGI. Past that point, maybe things still break, but for the purposes of making progress on AI safety today, we can focus on starting in the present, working our way forward. Okay, there are other beliefs that are correlated here. Right? So again, what's the right unit of analysis? Is it aligning present-day systems, improving the safety of current-day systems, or is it working backwards from the limit, thinking about what superintelligence looks like, reasoning a priori about how to ensure that system is safe, and then taking that backwards to us? The assessment of risk is different. The Uniformitarian camp will focus predominantly on threats like scheming, right? The idea that maybe it's inevitable that we're going to use AIs to automate the AI safety project for us. And in that case, the biggest risk is that those AIs lie to us, that they hide information from us, that they're deceptive. And so that's the main risk to solve in the near term. From then on, we can worry about other risks. On the other camp, just to say one additional thing about the Uniformitarians, right? If you're working your way forward, the portfolio of risks is broader. You think not just about misalignment risk, but you think about the risks of misuse, gradual disempowerment, maybe great power conflict, or a much broader portfolio. And if you reason backwards from ASI, maybe that's the biggest source of risk. All of the risk is concentrated in misalignment of superintelligent systems. And again, the sides are not always completely civil with each other. So I think both sides have a toy image of what the other side looks like. The Uniformitarians don't actually believe in ASI. They haven't actually grasped what strong superintelligence might look like. And on the other side, you have, what is it, basically like a religious doomer who hasn't coded a transformer ever. Okay, so I think we can do better than this caricature, and we can actually steelman both sides and then find a better synthesis. Let's try that. As in the case of the geologists, these are not just differences of hypotheses, but they're cultural differences. In different paradigms, they have different approaches to the world. So I think the most important one here is this idea of starting in the present and forward chaining to risk versus starting in the future and back chaining, starting at the limit of intelligence and back chaining. And these poles are associated with communal clusters. You have the more EA, frontier lab-oriented folks, and then you have the traditional rationalist, MIRI kind of AI safety. One thing I'm concerned about in the context of all of this is that at a high level, the field seems to be converging on roughly 2 meta strategies, I'll call them. One of them is we should proceed cautiously and automate AI safety full bore ahead. The other is we should pause, stop, and maybe augment human intelligence and worry about this later. Okay? And I'm worried about how this interacts with field level dynamics that are closing the labs off from the rest, that are turning this divide into an inside versus outside kind of thing that will solidify this difference and not make it a source of sort of healthy disagreement, but turn it into a full-blown schism. So maybe aim 1 is to point this out so that all of us don't do that and do something different. And then the second thing I want to do today is just reject the dichotomy altogether, right? Add more nuance and show that in practice, most people are somewhere in the middle, and intermediate stances are, I think, a healthier way to go forward. And I'll be articulating what I see as a third culture, somewhere in between these extremes. Yeah, of course, like this whole thing is going to be sort of artificial, and you should see that as accomplishing a pedagogical role. It's easier if we have this clear axis along which we can organize the field. But it's also just a rhetorical ploy. Like, it just helps to have these extremes and then to say that, oh, this particular intermediate path is the right way forward. So be wary of that kind of framing. Yeah, so let's talk about these differences. I want to talk about the differences in terms of beliefs, hypotheses, then the differences in approaches, research agendas, and then the communal differences, the more sociological aspect of these differences. So, as I see it, the fundamental crux is something like, how discontinuous is AI progress? This is correlated with a lot of other cruxes that people have. Like, how strong can ASI get? How fast is takeoff? Does recursive self-improvement cause a discontinuity? How soon after AGI does takeoff happen? Even in the uniformitarian camp, most people buy that we're going to get really crazy technological progress in a short period of time, and that it could go very quick. The disagreement is more along the lines of, like, is that a kink? Is that a sudden discontinuous change, or not? And how quickly after we reach something like AGI does this happen? How jagged is intelligence? Is it just inevitable that as we push further, there is some general core of intelligence that means these models will suddenly generalize far distribution and inevitably end up with sort of consequentialist cognition? How unnatural is corrigibility? What are the central problems? We already talked about this one. In particular, how much useful research can we get out of the models before we reach the point at which it's too late and we can't productively proceed? And I think the main temperamental bent that people have in the community, optimism versus pessimism, although it's a very cautious optimism, is also downstream of this. If you think that there's this discontinuity, most of the risk is concentrated in that, and most of the work we're doing does not hold across that discontinuity, yeah, it's a hard problem. Okay? It's one big problem that we don't have much of a handle on. If, on the other hand, the work we're doing now, it's iterative, closing the gap step by step, is making real progress, if that gets us closer, then maybe we do have a handle. We get lots of practice before it's too late. One thing I want to point out is that these are ancient divisions, okay? Ancient isn't like, 2 decades, well, 2 decades, that's for AI, that's ancient. So the cultural divide isn't new. I think there is a sociological trend that's happening where a lot of new people are entering the field, primarily through uniformitarian funnels. And so increasingly people are blind, or I won't say blind, they are not aware of this history, and the catastrophist cluster gets downweighted, de-emphasized, and doesn't get enough attention anymore. That said, I want to point you to some readings, homework for the next lecture, if we have one. These are old debates. What'll be new is, I'll talk more about the sociological side. That's not something that comes up as much in these older works. Okay, so how discontinuous is AI safety progress? That's the fundamental crux. It's an old crux. It's been some time. We have new evidence. What does the evidence from the last decade say about this point? And I think really there just is evidence for both sides. So the thing the uniformitarians will point to is scaling laws. Right? We see these incredibly uniform straight lines on log-log plots relating our inputs, so parameters, data, compute, to changes in output behavior. On the other hand, we know emergent capabilities are real, right? Along any of these axes, as you scale model size or training time, you can see models, in some cases, quickly jump from next to no performance, random performance, to something very competitive in very little time at all. And the smoothness of the overall performance hides these discontinuities. Moreover, there's increasing evidence that the critical exponents characterizing these laws can change. Sometimes this is just for methodological reasons. Right? Chinchilla showed us that we were kind of calculating these scaling law exponents in the wrong way. You can do better. Others are from possibly actually algorithmic improvements. So in context learning, if you read the original induction heads paper and work around that, they argued that the formation of induction heads and the acquisition of in-context learning is associated with a potential change in the scaling exponent for these models. And it's possible that other algorithmic improvements also lead to changes in these scaling law exponents, which could lead to sudden compute overhangs being reduced and progress changing quite a lot. Another strong piece of evidence for continuity is the meter time horizon trend lines. That's a straight line if I've ever seen one. On the other hand, we have seen this kink since the reasoning models. So straight lines, sure, but there are discontinuities even on those curves. Classic uniformitarian point would be that recursive self-improvement is already happening. People are already accelerating themselves. We're getting maybe a 2x uplift right now. That'll increase smoothly all the way through the 10x uplift and beyond. And then this is a straw man of the catastrophist point, but real RSI has never been tried. Okay, so maybe we're just not there yet, and there is this intelligence explosion that still happens in the future. So far, the world seems to be changing pretty continuously. This is very much subject to debate, but we have seen distribution shifts that lead to sudden changes in behavior. I think Sydney Bing was the classic example. Maybe recent things with long context drift of models, and we have theoretical arguments along the lines of the sharp left turn. Even algorithmic process itself, some argue, can be quantified and made pretty smooth and consistent. This is what Epoch has been doing. But we have seen discrete algorithmic progress happen. There are points where there are actual changes in these curves. So, overall, I think the sense is that the uniformitarian cluster is winning this debate, but I would say the debate is not yet resolved, and we should hold off on announcing anyone the victor here. So, yeah, evidence goes both ways. So I call these different research cultures, and part of a research culture is what is your understanding of what are the methodologies you use. So I pointed out this distinction between sort of an epistemic stance of starting in the present and forward chaining versus starting at the limit and back chaining. There are other differences here. So in style, the uniformitarian cluster is much more empirical, whereas the catastrophist cluster is much more theoretical. So part of this is because how do you do empirical research on a limit that you haven't accessed yet, right? Theory is the only thing that you can do. But in working our way forward, empirical work is often easier. It's more tractable to make initial progress on than theoretical work. So I think for these reasons, it's very natural that this has become correlated with the other axis. And as we talked about, a different perception of what the problems actually are. Yeah, so let's talk a little bit about concrete research agendas and where they fit in here, with the understanding that this dichotomy, again, is a little bit fake and you shouldn't overrank on it. The classic distinction is prosaic alignment. What is prosaic alignment? We're using the same deep learning techniques we use for capabilities that labs are already using, and we use that to train against specifications of values instead. And that's the current mainline strategy. On the other side, you have agent foundations, where we start with trying to build mathematical models of what superintelligence would look like. Now, the thing about these models is we know for a fact that they're incomplete. So there are kinds of paradoxes and problems we can come up with where we see that even our, the mainline model of superintelligence, AIXI, makes the wrong decisions. So one immediate avenue of research is, can we improve these mathematical models to actually end up with models of superintelligence that are optimal along all the different avenues we can identify. On the forward chaining side, evals and forecasting makes a lot of sense. If you know that the capabilities of the next generation of models are going to be a small delta away from the capabilities of the current model, forecasting obviously makes sense in light of all the straight lines on graphs we've seen. On the other hand, you have deep philosophical questions like, how do you unify logical and probabilistic uncertainty? So an optimal reasoner is going to have to deal with uncertainty in some optimal way. But we have these two different kinds of uncertainty in math. We have probabilistic uncertainty and we have logical uncertainty. And it's not a priori obvious how to combine those and how to end up with better models of superintelligence that combine these. So again, in the limit, these might seem like quite abstract problems, but if we're ending up with superintelligences, these kinds of questions might really come to matter. Control is a canonical example of something that's forward chained, right? Pretty much everybody in control, and I don't want to, I think it's important to emphasize that most people, many people in the uniformitarian cluster recognize that the kinds of deep philosophical problems on the other side are likely to become necessary at some point. Okay, but then the move is to say that's not a problem for us to solve. That's a problem for future generations of AIs to solve. Our immediate pressing priority is to ensure that we have an AI scientist that we can trust. And for that, maybe it's sufficient to rely on control kinds of arguments. We don't even need to necessarily align this model robustly. We just need to make sure that we can trust its outputs. And if we get to that automated AI scientist, well, it'll help us with whatever the next step is after this. And if that next step involves solving these thornier problems, so be it. That's what we'll do. On the other side, some of the questions you end up with are not just, can you come up with better limiting models of intelligence that don't have these limitations of our current models, but can you come up with more realistic models? So AIXI, for example, is not a physically realizable system. So somehow you have to turn that model into something that actually can be implemented, and you want to work your way backwards to something more realistic. This is, for example, where a program like embedded agency comes into play. So we're taking steps towards more realistic systems. Interpretability, at least in the canonical ELK-style framing, where what we're doing with interpretability is something like trying to distinguish a model that's deceptive from one that's not deceptive, trying to understand what it actually believes. In that case, right, this is a very forward-chained kind of theory of change. Maybe down the line we can use this to improve our targets for aligning stronger intelligences, but well, traditionally this is more in the forward-chained cluster. I want to highlight Vanessa Kosoy's learning theoretic agenda as something that also often reasons backwards from limits. Well, and there's much more. Yeah, we'll come back into this later, but selection and coherence theorems I'll highlight as another example of once you have statements about the kinds of properties you expect these limiting systems to satisfy, can you say something about how a real-world system converges to those properties? Can we actually prove that these things are favored under the kinds of learning setups that we have today? Okay, so maybe this helps sort of orient where these different research agendas come from. That brings us to the communal aspect, the sociological aspect of the difference between these communities. So it's not quite perfect, but roughly the communities correspond to the rationalist cluster and the effective altruist cluster, which got into AI safety through different means. There are different historical lineages here that show up as, I think, philosophical differences in the present day. Where did rationalism come from? Originally from transhumanists and the singularitarians, who were already reasoning about the singularity. Then Yudkowsky comes along and says, it seems like succession doesn't imply that human values will survive across the singularity. That seems like a problem we should work on. And from there, Less Wrong, Mary, and modern rationalism. This was in the early 2000s, right? So it's not yet clear exactly what discipline superintelligence is going to come out of. Deep learning hadn't taken off yet to the degree that it would a decade later. So what disciplines do you bring to bear on this problem? Well, you inherit many of the disciplines from the singularitarians. This focus on enhancement of the self, like overcoming your own biases and limitations in order to become a worthier adversary for the future ASI. Probability and decision theory, things that we think are general enough that they'll survive any kind of transition. Working backwards from the singularity. This is an inherently more libertarian, individualistic culture. And like I said, at the time deep learning wasn't yet visible, so exactly how you get a handle on this problem isn't immediately clear. On the other hand, you have the effective altruists. So this is coming from a tradition started with Peter Singer and earlier, that led through McCaskill and Ord to EA as we know it today. There, the starting point is moral philosophy, expected utility. It's thinking through thought experiments like the drowning child. And very quickly, through some of these thought experiments, you end up generalizing to consequentialism, expected utility maximization, to the idea that your notion of good should be distance, should be insensitive to distance. Right? A drowning child in the pond next to you is worth as much as a drowning child the world over, so you shouldn't discount across distance. A simple generalization of the same argument means you shouldn't discount across time. The future matters as much as now. And given the fact that the future is very, very large, maybe all of the values in the future. How do you ensure that we achieve value in the future? Well, that's quite uncertain. There's very little we can do. One thing we can do is make sure we get to the future, that we don't succumb to some kind of X risk in the process. And that's where long-termism turns to X risk prevention. And then once you do your cost prioritization, you identify superintelligence as one of the main risks, so you start working on that. EA is inherently more communal and institutional, whereas rationalism is more wary of institutions. And it comes online roughly at the same time as deep learning is taking off. And so this is just suggestive, but it doesn't surprise me that the thing you latch onto then is whatever discipline is coming online at the time, and that you start working on more prosaic approaches to AI safety that are grounded within contemporary machine learning. So I'm not arguing that either is better than the other. But there are some differences. Right? Over the last decade, over the last 2 decades, there's been sort of systematic differences that have been selected for. Okay, rationalism selects for more independence and decoupling, whereas EA relies a lot on willingness to work within existing structures, willing to defer to the opinions of many trusted people around you. Rationalism is inherently more low-level, long-horizon work, at least the kind of agent foundations work that people worked on originally. Even the sort of funnels we have for bringing people into these fields. On the one hand, you have H.P. Moore and the sequences, and on the other hand, you have organizations like ADK that are designing structured paths, structured entry paths into the field. And so what's happening over the long run is that EA is professionalizing more, it's becoming larger, more money is streaming in because it's more tractable. So this bucket is growing in scale, whereas I think this one is relatively stable across time. And so, see this, we had a lot of maths mentees here. Check yourselves, analyze what's going on within maths and see if you notice any of these sort of macroscopic trends that are going on within this community. That said, right, the boundary between these two is extremely porous. People flow between the two. They enter at the same time through both channels. EAGs are the original AI safety conferences, et cetera, et cetera. So I don't want you to over-anchor on this distinction. Okay, so that's the present day. We have these two communities. They have different correlated cruxes and approaches and communities and gathering places, even physical locations and key figures. What's going to happen with this? Where is this headed in the future? Well, a schism, I sure hope not, and maybe I shouldn't even use this language because it kind of brings into existence the thing that we're trying to prevent here. But I think it's a real risk, and I think we should talk about it. So here's the original strategy, the original Yudkowsky-approved strategy. Right, we're going to solve alignment in time. Ideally, this is a small team. Maybe this is even the AI safety community itself, working in secrecy, working faster than other teams, and being the first to arrive at superintelligence. And then you have potentially this quite brief window after AGI, before you get this runaway intelligence explosion, before you get some discontinuity, in which we can use this AGI on a very narrowly specified task, which is going to be something like design nanomachines to melt all the GPUs. This is like the modal plan, classically. The pivotal act, right? And the acute risk period, buy us more time to then solve the harder problems over longer time horizons. But make sure that no other team can then come in and defect for everybody. So roughly there's a split happening into two different strands now. The MIRI recently shifted fully to technical governance. So they're not working on technical AI safety anymore. And the strategy is something like pause, buy time, maybe through international coordination. And then it depends on who you talk to. Again, this is not the common opinion of everybody in the community, but some will say, and then we should invest in intelligence augmentation and let humans, very smart humans, over the next decades solve this problem for us. On the other side, you have people who aren't even necessarily against a pause. They're just willing to entertain the possibility that the pause should happen a little later, who say something like, we should proceed carefully. And we're going to buy time, not by augmenting humans, but by outsourcing a lot of our research to AIs. And an output of these different perspectives is this crux on how we view the frontier labs. One group of people says, don't work at the frontier labs. Sort of like, it is a sign of virtue to just refuse to engage with the frontier labs. On the other side, you have people saying, labs are high leverage. This is where you could have the most impact because you're close to the things happening. You are then in a position of power potentially that you can yell stop when it's really time to stop because you don't want to do this prematurely, sort of burn the goodwill. And you get this difference in attitudes. I think what's changing is a few things. Right? Number one most important thing is that we're getting closer to AGI. And it's sort of inevitable that as this common enemy that was out in the distance that previously unified everybody comes closer, that people will balkanize. They'll disagree on exactly what the definition of AGI is, exactly what the definition of RSI is. They'll disagree on how likely it is, increasingly, that we'll align models successfully, and they'll disagree on whether they believe there's enough time to solve the harder problems. The labs are closing off. I think so far this hasn't actually happened to a massive degree, so maybe the wording here is too strong. But there's a risk that as the models become more capable, as the frontier models become gated, that most people will not be able to have any impact anymore on the field. Right? So whether you're inside the lab or outside of the lab, your action space sort of collapses. And there's just less that you can do on either side. And even within the labs, you might deceive yourself about how much influence you'll be able to leverage once automation has really taken over and starting to replace humans. So this inside versus outside distinction is the one that I think is most dangerous. But most of all these things means that the stakes are rising. So that means in some cases that energy is going to redirect to advocacy and pulling in more and more people. Public advocacy becomes possible in a way that it wasn't beforehand because the things are just more visible to everybody. And you even get these cases, I think, of violence from the really desperate that start further turning this into in a sort of aggressive, ingrained divide. Okay, so let's not do that. Okay, let's do something else that isn't this. And I'm going to be talking about kind of a third culture, some strands that I think are between these two poles that give us a better chance for the field as a whole to stay healthy and to solve the problems that we're going to run into. So this is where I say that this whole dichotomy I gave you is just wrong. Like if you look across the field, most people are somewhere in between. Basically, nobody is fully on one pole or the other. It's kind of an imagined cluster of things. Okay, so an example would be arc theory. Like historically, Cristiano was Joukowski's foil. He was prototypical example of the uniformitarian cause. But arc theory is much more friendly to theory than most people in uniformitarian camp currently seem to be. Okay, so these things are not actually at odds. They can work together. I think AI control is another example. Maybe it's easy to point out a lot of empirical work that has come out of this, but it's very easy to imagine a version of control that is a more theoretical approach to control, that uses ideas from cryptography to study steganography in deeper ways, that uses ideas from, for example, game theory to study the equilibria of control protocols and to understand whether the things that are selected for are actually good. And in fact, this is already happening, right? So the divide is not pure here. Again, on the question of pause, I think basically everybody, well, most people support the idea of a potential pause at some point, if it's necessary. And the question is really not to pause or not to pause, but like when are the stakes high enough that we should pause and hit the stop button? And in particular, what form should it take? Within each pool, there's as much variance as there is across pools, potentially. And there are other ways to cut that I think just don't buy into the framing that we have here. So AI governance and gradual disempowerment, those are slightly different ways to look at the problem. The unit of analysis is different. Maybe it's just not the AIs that we should be interrogating as the fundamental unit, but some other thing. And so I could go on with this list for many more pages. I won't. We'll let you sort of generate this yourselves. Go look for counterexamples to this. There are many. That said, I still think the pools point to something real, and that both pools are missing something, or missing several things. So what are the catastrophists missing? I think there's plenty to work on now that is theoretically interesting, where we expect now, with high confidence, that the techniques we're studying will generalize to superintelligence. So a good example of this would be learning. Right? We expect future systems to be built out of learning. And so questions that are fundamental to learning theory, like generalization and optimization, you actually end up at the target that you originally specified, are high leverage places we can work on now, that we can build up a more theoretically principled understanding, and that we expect it to hold into the future. One thing, an aside that I'll offer here, that I think along some axes, the catastrophists have predicted more of the relevant changes over the last decade than the uniformitarians have. So take the example of simulator theory. Right? When the models were still basically just base models with a shell, there is this whole empirical strand that focuses on, oh, maybe if we condition these things right, if we chain them forward, if we forward chain from this kind of base model paradigm, things are just pretty safe in an easy way. But then we got RLVR. I think many catastrophists would say, obviously we got RLVR. Have you studied your ICSI enough? I mean, yes, you need your prediction, but you also need your sequential decision theory. This is just completely straightforward. And if you had thought from within this frame, then you wouldn't be surprised by the fact that the simulator frame just kind of totally collapses. And you're not going to over-anchor on this idea, for example, that, oh, the AIs, they have this wonderful prior of human knowledge. And outer alignment is actually solved because, you can just talk to them and they understand what our values are. But then if you think about how much the RL part of the trading paradigm is growing, what you start to think about is that we are going to burn away this human prior very quickly. Okay? Do not over-anchor on maybe this traditional frame. And you think, you might reason yourself into a sort of sense of complacency that the current things are going to last longer than they actually do. Another thing I think the catastrophists really are missing is that automation is going to help. Okay? So we're seeing that automation is making meaningful progress, in particular on theory. Right? The places where we've seen the most dramatic advances, things like the unit distance conjecture, that's starting to work. And this is going to work much, much better very, very soon. And this is kind of outside of the standard catastrophist model of how things would go down. There's sort of a common understanding that the ability to do math was much more correlated with agency, and therefore once you cross this threshold, maybe you're already past the risk threshold. But that doesn't seem to be true. And because this is different from the conventional path, I think people are underweighting the importance of automation in the next few years. And I think that there's a real point to the man on the inside, that cutting off ties with the frontier labs would be bad because it just means that there's no more accountability. Everybody loses access to actions that they would have had otherwise. Now, maybe the catastrophists are right to question whether people are actually able to credibly yell stop when it's time to stop. but better to have the option than to not have the option, I would say. On the other side, what are the uniformitarians missing? Well, we still have to align ASI at some point. Right? I'm taking as given that the people in this room believe in the possibility of strong ASI, and that there is still a big difference between AGI and ASI. And it's simply the case that the bitter lesson applies not just to capabilities, it also applies to alignment. So most safety work that people work on is just not going to survive the next few years of progress. This is true for everybody. It's unfortunate, but this is what it is. The uniformitarians, as a whole, over-index on scheming. In a lot of communities, you hear people talking about scheming. Scheming is the only risk. And that seems pretty worrying to me, right? Scheming is one risk. It's not clear even how much evidence there is for scheming, but the monoculture here, when we're talking about the distribution of risks, seems bad. And we'd like to encourage people to sort of at least go back to the conventional discussions of risk, go back to the original Cristiano work in thinking about the distribution of risks in a broader sense. There's this overall bias towards doing tractable things that will veer you ever so slightly away from doing the things that actually make a difference. So John Wentworth wrote a piece, a post-mortem on the field that I think everybody here should read. It was scathing and maybe a little bit more aggressive than it actually needed to be, but it makes the point that what seems to be happening is that almost everybody in AI safety is doing this mental move where they look at a hard problem and think, oh, I can't solve that, so I turn to a slightly easier problem instead that is no longer on the critical path. This is just so easy to fall into. You don't even have to be aware of it. It's just what happens. So, be aware of this. I think in the case of maths, for example, it's great to work on something tractable. I encourage everybody to work on something tractable for the next few weeks, because building experience, understanding the field as a whole better and actually making progress makes you a better researcher often. But you should be very clear about the choice you're making between maybe working on the actual harder problems versus building career capital, building general research skills, and actually converging towards the things that matter. On the automation front, I think the uniformitarians are missing the question of what are we even going to automate? Okay. And I claim the answer is still maybe the crazier philosophical questions that the Agent Foundations folks have been trying to get us to think about for a long time. Okay? Maybe theory of what happens in the next steps is the tractable target, is the thing that we should be aiming at, rather than just purely accelerating the empirical work we're already doing. We need a target, and moreover, we don't just need a target, but we need some way to verify that we are making actual progress. And that is much harder to do with empirical work than it is with theoretical work, where you have an external ground truth. And another thing I think that the uniformitarians are missing, maybe this is too confident as somebody coming from the theory side, the inevitability of theory. Right? If you look throughout scientific history, it is always the case that fields start with empirical tinkering, and that the empiricists think, oh, these theorists are thinking off, their heads are in the clouds, they're not doing anything that's relevant. And at some point, theory just takes over. Because the search space as an empiricist grows larger and larger as the systems become more complex, and as the systems are pushed further and further out of distribution, that at some point you need some kind of thing to filter your attention and narrow it down on the most relevant questions. And that's what theory does. And a purely empirical approach is not going to survive across however many further generations we get as the affordances of the models increase, as their action space increases, as the size and complexity of these systems continue to increase. Okay, so where does that leave us? And so I have throughout this talk sort of sketched this division of people who are thinking about fast discontinuous progress versus slow continuous progress, and back chaining versus forward chaining. And I called it the Catastrophists and the Uniformitarians, following the same divide in geology. What I want to do is pull this apart. Okay, so I want to add another axis to the distinction. And I want to distinguish the theory first versus empirics first, contrast from the back-chaining versus forward-chaining contrast. And again, these terms are not quite perfect. So theory first is not entirely what I mean here. But I want to argue that there's this third culture. It's the third culture of arc theory nowadays, even though they started maybe in the Uniformitarian camp. It's the kind of work that we're doing at Timaeus. I think that Chai assistance games fall into. Scalable oversight is a canonical example. I even grouped some of Case and FAR. So I think Case and FAR are examples of more empirically focused work, but they distance themselves from either extreme on these sides, neither the rationalist cluster or the EA cluster. Okay, and I think that there are some ideas here under this third culture heading that we should borrow and think about going forward. So what does this look like? Forward-chained, theory first, aiming to clear a higher bar. One is, we're aiming for higher confidence via a combination of theory and empirics. Not theory on its own, not empirics on its own, but some combination. We don't expect to get strong guarantees, but we think there's progress that could give us additional confidence beyond what we have now. This belief in a portfolio of bets, a stance against monoculture, and the over-indexing on a narrow set of possible risks, where any of these bets is likely to fail, but also any one of the bets could make a big difference if successful. Taking research automation seriously and potentially diving fully into this in the next 2 years, as aggressively as possible, with the understanding that theory gives us, in many cases, a stronger filter with which to advance research automation. And finally, the sociological point, at the boundary, not inside or outside the labs, a third-party ecosystem in the tradition of Apollo, Redwood. Right? This is actually happening. There are people who are at the interface between the labs, and building this up gives us enough credibility to both make a difference in what's happening inside the labs, and to credibly yell stop if that becomes necessary. So I want to present 2 examples of how I think this kind of perspective can cash out. And the first one I'll call the scalable oversight theory of change. This is one I credit to Jeffrey Irving. And it looks something like this. Okay? We don't know what we want to align the models to. Outer alignment still isn't solved. We don't know whose values, what values. We don't know what we would endorse reflectively after we'd had 1,000 years to think about this problem as further enhanced humans with a country of wise elders in a data center. What do we do instead? Well, maybe we pick out a set of minimal values that we think retains optionality later, that gives us the freedom to do this thinking later on. An example would be honesty, right? That you can actually ask the question and expect the answer it gives to be the answer that it actually believes. And maybe if you pick the right ones, you can work on instilling those values in your system and generalizing from there to the full picture. You bootstrap your way up, one value at a time. Here's one approach to getting more confidence in this plan than we have in the current plan. So you're going to use ideas from complexity theory, maybe game theory, to study scalable oversight protocols and prove that the equilibria of these oversight protocols satisfy your desired property in some formal sense. Now you train against this protocol. Okay, you're going to train, and you won't end up exactly at this equilibria. You'll end up at some gap away from the equilibria. And the question is, how big is that gap? What's the nature of this gap? And this is a problem that has a natural home within learning theory. This is the question of generalization. So maybe using learning theory, you can characterize this gap through new interpretability tools and eventually close it by developing better training methods. Maybe there are interactions with other areas like theory of personas. The space of latent variables that actually seems to characterize behavior seems to be much, much smaller than the full space of parameters in models. And by combining this, we get additional leverage on these other questions. And so what we end up with is not confidence that we got something right, but a procedure with which to continually continually close this gap between the solution we actually get and the theoretical optimum, which satisfies the properties we want. Gives us a way to inject compute and scale up the compute to get closer and closer to the target. Here's another example. It's the Timaeus theory of change, what we've been working with. We see alignment as a problem of generalization. And generalization has a natural home within learning theory, like I just said. So we just need to solve generalization. Okay, so here's the series of steps. 1, let's understand alignment as a problem of generalization using tools from singular learning theory. Let's develop new interpretability techniques grounded in this framework that relate model internals to generalization directly, that provide some principled link between these two things. And then let's turn this into a set of tools, what we call patterning, for changing the data mixture to achieve the desired generalization behavior, to achieve the desired internals via what we call susceptibilities. If you combine this with knowing how to translate human values into the language of these susceptibilities, these measurements of generalization, then you're done. Right? You've turned training AI systems into something that looks more like programming, and growth into programming, and we just know how to do the next thing. And I think it's important to realize that you don't need to close this full picture in order to actually make progress. So for example, alignment today is currently already some kind of constrained optimization problem. You've got these huge teams, many, many different teams, working on satisfying different parts of the specification. Your model should follow instructions. It should speak multiple languages. It should refuse on harmful queries. And so on. It should be cheap to run inference on. You've 100 different specifications like this that you're trying to satisfy. The problem with current practice is that the training pipeline is serial. So each time you try to satisfy a new criterion, trying to get math performance up past some threshold, you can break other constraints. Okay, so our approach is a soft form of constraint optimization that sometimes doesn't work. And an immediate improvement on this is if we have more principled ways to enforce simultaneous constraints and higher order constraints. For example, I want my model to use the same machinery to solve these two different benchmarks. Or I want to satisfy both the harmlessness and helpfulness data sets at the same time, as opposed to these conflicting with each other otherwise. And these are the kinds of improvements that we expect to be able to roll out of our agenda. So these are both examples. How much time? Okay, wrap it up. I'm almost done. So these are examples of the kinds of approaches you get by combining theory with empirics in a forward-chaining way. Now, this is working. We're getting closer, and I think there's just a straightforward path to impact here. And it's possible. Right? I think other organizations have demonstrated that you can sit in this intermediate regime and actually make a difference. Yeah, so to close off, I want you to take a look at this picture. Right? So 65 million years ago, and one dinosaur says to the other, "Hey, did you hear? The geologists have found this beautiful synthesis. Oh, actually, geology evolves through both steady changes and occasional discontinuities." The other dinosaur coughs. "Oh, gee, what a relief." And then they both die. Okay, so as we zoom in, what we're looking at here is the KPG impactor. So this is dinosaurs, 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 asteroid, and the rest of society, okay? So for all this talk about achieving a synthesis, let's keep in mind that the problems might be quite hard, and let's not do what the dinosaurs did. Thank you.
Thank you so much, Jesse. Appreciate you coming out. We're at time, so yeah, just join me in thanking Jesse for coming out today.